Welcome to the Edifice Complex, the property design and development podcast. Let your hosts Adam Muggleton and Robert Bean keep you up with who is innovating and doing great work, perspective on the adjacent possible, and challenges to the status quo.
Welcome to the Edifice Complex. I'm Robert Bean, your co-host and unofficial mediator here with my colleague, official agitator, heavy emphasis on agitator. How you feeling this morning, Adam? Agitated?
Wound up right now.
It's election day in Canada. Anyways, friend and Yoda of most everything to do with buildings, Mr. Adam Muggleton. Say hello, Sir Yoda.
Hello there. So this is an interesting one for me. So just to come clean on everything, Nick, who's on today, is a friend of mine. We work together. Obviously, I'm a fan, but we're going to explore some subjects here that I think are really important. So let's crack on.
Yeah, today's guest is a chartered engineer and fellow of CIBSE with 21 years postgraduate experience in the construction industry. He's a past recipient of the Construction Weekly Magazine MEP Award, Mechanical Engineer Year of the Mechanical Engineer of the Year. That's an awesome thing to have on your resume. Yeah. He has experience working on projects involving natural ventilation, HVAC, heat recovery, solar thermal, photovoltaic, rainwater, and my favorite, concrete core cooling. I love that. Much of his experience has been in the Middle East and leading MEP designs for high-profile clients. Heavy emphasis on high-profile. Projects include 5-star hotels, hospitals, retail malls, educational institutes, and museums. He's cut his teeth in Europe and the United Arab Emirates with Max, Fordham, WSP, Hyder, Arcadis, Aegis, and now Director of Building Services at AESG. Welcome to the show, Nic Byczynski.
Thank you very much for having me.
Yeah, Nicholas, I love how you earned your honors in mechanical engineering, and then you recently earned your executive MBA. When you stand back and you look at your academics and then your practical skills, and two of the most amazing places in the world with some of the top engineering firms, you've had quite the ride there, buddy. Tell us your story. Like, what drove you all this energy to put you where you are today?
Thank you, Will. I mean, it has been quite a ride. I think that's a good way to describe it. I started sort of out of university in London, in MEP Fordham. It's a fantastic place to work. I'm not going to lie to you. I fell into the industry almost totally by chance. Came out of university with a degree in kind of pure mechanical engineering. Didn't really know what I was going to do, but I knew that I wanted to go traveling to Australia with my girlfriend, and went to a bunch of interviews, and I was lucky enough to get offered a role at MEP Fordham's. And I'll be totally honest, I didn't really know exactly what building services was almost on the day that I turned up. And actually, despite really not planning it, I actually fell into an industry that I've come to really love and a job that I really enjoy, despite how difficult and unrelenting it can be sometimes. So I did 5 years in the UK, and then through various reasons, I felt like I needed a bit of a change. And I was aware of the UAE through some family connections, and thought, you know what, that sounds like it might be quite fun. So I'll give it a go. And packed up my suitcase and got on a plane, and I actually arrived in the UAE in December 2008. Which for historians amongst you, you may realise was not a particularly good time, because by January 2009, essentially the entire world had collapsed, and particularly the UAE market. So I had a really, really kind of rough introduction to the Middle East environment for kind of 18 months. Like many people at companies that were losing staff at a really, really serious rate. But I was lucky enough to kind of keep my head down, and through couple of people that kind of looked after me during that period, managed to kind of survive it all. And then from then on, kind of got on my feet a little bit. And, what was meant to be a year in the Middle East, 16 years, 2 children, and I'm still here and got no intention of going anywhere else, to be honest with you.
Well, it's an awesome place to be. There's so many things that we're going to be talking with you about today. Something just triggered when you mentioned that you managed to make it through a real difficult time through the help of some people.
Yeah.
Expand on that, because, a lot of our listeners, are kids that are in school. And there's, in the world of construction and engineering and architecture, those mentors are incredibly important. for you, the people that sort of take you under your arm. Tell us about how you managed to survive that with that help.
Well, look, I mean, I think, there's one guy in particular, best engineer I've ever worked with, a guy called Peter Cummings, who remains a friend of mine. I like to stay in touch. He taught me a huge amount about like being a good engineer. But, actually, there's no other way to say it. During times when people were writing lists, he never put my name on a list. And, he even though I hadn't been at the business that long, and, obviously there were very large cuts going on a fairly regular basis through particularly 2009, for whatever reason, he saw something in me that he wanted to keep around. And, that's the only reason I'm still here, to be honest. I'm kind of eternally grateful to him for that. And, and everything else that he taught me on the technical side, really fantastic engineer, and his mentorship coupled with people, specific individuals I worked with at Max Fordham's kind of really, I guess, set me on a path to, I don't know, give me like an idea of what I wanted to be as an engineer and how I want to be as a leader of a team, and how I would like people to kind of look to me to help them in their careers, if you know what I mean.
Yeah, no, I do. Some people who, and Adam, I'm not sure where you fall into this camp, but some people strategically seek out and court mentors. Like, other people come by it by chance. I certainly came by it by chance because I was too stupid to recognize good people around me.
Oh yeah, I was aggressively stupid till I was about 35, and I just got lucky. I had a few people who go, "Oh, I'm going to save this idiot from himself." But
when you look back and you think about those people and how important they were in your life and your career, those moments were not just, not skill development. They were human development. Like oftentimes the mentors I had in my life carried a big 2x4 and hit me on the side of the head when I needed it. And, it was painful at the time to hear people that you respected give you shit and, tell you, like you have to have had an attitude check there. But in hindsight, they were right. And, if you don't make those alterations, then you're screwed. I mean, these were smart people, and but by making those adjustments in your navigation, it helps your career path for sure.
Yeah, and I think it is as well. Some of the stuff is just a little takeaway. I remember one guy who used to do the technical mechanical reviews at Max Fordham's, and putting your design down in front of him was a really scary experience because
it pushing it across the table,
taken to pieces. But he'd always say, we have to be our harshest critics, because if we can comfortably come through this process and look at what we've done and go, do you know what, we're happy with it, we need to trust that anybody else who looks at it is also going to be happy with it, because we are as good as them or better. So you have to really be very critical. And again, that's something that I've really taken away. I always push myself and push my team to really, really, really focus on picking apart their own work, because if we can't find fault with it, then we need to assume that others won't be able to either as well. So I think that's an important takeaway I have.
That is so true. Every once in a while I'll go down memory lane and I'll pull out some old drawings that I did from like 10 years ago, right?
What was I thinking?
And I look, no. Well, and it was funny because this is going back into like, I think my first drafting class, like this was long before AutoCAD, like this was pencil and paper stuff. This is Mylar and pen stuff. And I remember, one of my first lessons and it was about your line drawings and trying to avoid crossing. Like if you can keep lines parallel and perpendicular, but without a whole bunch of lines crossing back and forth, that it was just so much easier for people to follow the drawings. And I carried that through my entire career doing design work, and then of course passed it on to my students. And when you pull those drawings out and you look at the drawings that your design team did compared to other people, and the clarity it was to be able to interpret those drawings. And it's just so much easier to see it three-dimensional, because that's ultimately what happens on the job site, right? And that's just like one micro bit of advice that someone give you. And if you apply it, then over a career, you get thousands of those micro advices. right?
I think, so sometimes I think engineers are good at many, many things, but communicating our ideas with non-engineers is a massive weakness in the industry a lot of times. And I often talk about the need to, be able to communicate with real people, because, so often, people get themselves caught up in codes and standards and technical bits and pieces, and you can see them in a meeting talking to an architect or a client, and you can see that they've lost them almost instantly. And you're like, guys, you need to think about communicating to everybody else that isn't you. And like you say, whether that's in the drawing and just having it clean and clear and laid out nicely, that's a really important first step. I mean, actually, I think one thing now which I absolutely love is the fact that we're not doing black and white drawings anymore. Because of Revit, we can do double line on everything. So all of our drawings, the ductwork all color coded. So you look at it and you go, green, that's a supply duct. Red, that's a fire rated, smoke extract duct or whatever. And the difference it makes in being able to quickly analyze and review documentation is amazing. But then we're still seeing people that are still working in black and white, which I find is really odd because it's just so much better. And the argument I've heard is, well, it's more expensive to print. Who the hell's printing drawings? When was the last time anyone sat there with an A0 drawing? I don't even know how to use our printer in the office.
Actually, I'm just thinking, I don't know where the printer is in the AESG office. That's funny. God, there's so many takeaways there. The guy who trained me, if he had a clash on site, he used to take that so personally, which normally involved me suffering, but that's another story. But, and this is the problem with some of the IT tools, right? They sort of de-skill you and you lose that thing Robert was talking about, the power of a clean drawing with no clash. That's what people are paying you for. My latest obsession is essentialism, where like you just strip it back to the basics. What does a client want? He doesn't want to know your struggle with your IT or BIM or Revit model. He wants a freaking drawing with no errors and omissions. It's pretty simple. Right? So, people lose track of that. And shout out to Peter Cummins.
Sure.
He is your daddy. He's not your father, but he is your daddy, right?
Good stuff.
Yeah, good. Look, one thing I do want to talk about is, and this sort of segues in with the power of mentors. Where you start your career actually matters, right? And let's face it, that's just dumb luck, right? I mean, no one wakes up in the UK and goes, I want to be a building engineer. Mum said nobody ever, right? But you started out at Max Fordham Partners, which is quite the story. So for people not in the UK, Max Fordham Partners were one of the IT firms. They had this reputation of excellence. They were early to the sustainability game, and coming from there was a bit like having sort of like gold card on your CV. Do you know what I mean? So what was that like, Max Fordham Partners? Tell us a little bit about that. Why was that a special place?
Look, it was brilliant. For me personally, it's a combination of lots of things. Being in my kind of early to mid 20s, living in London, at the start of my career, that was quite a good time anyway.
Yeah.
But there's something about that company that I always felt was quite special. It was a limited liability partnership. It still is a limited liability partnership. So basically, everybody there after 3 years gets offered partnership. So that really changes the way that people think about the business, and that's not just engineers. If you're the cleaner and you were there for 3 years, then you would be offered partnership, which really created a very inclusive and cooperative working environment. I always sort of used to describe it as something like an engineering hippie commune. Hang
on, let me write that down. Engineering hippie. I never heard that.
It's exactly what it was like. It was a brilliant place of really, really smart people, and generally, quite an eccentric set of people a lot of the time. And part of the reason was they didn't really, certainly at the time, again, I haven't been there for a long time, they didn't hire building services graduates. They hired graduates, and then they taught them to do building services. So I did mechanical engineering. I didn't do building services engineering. And the guy, so in my little bay, the guy who sat opposite me had done astrophysics, and the guy who sat next to me, I think, was a biologist. What they wanted was people that had a basic understanding of science and first principles, and then they taught them how to do what they felt was the easy bit, which is building services. Because one of the Max has got so many famous quotes, and one of them, which I will absolutely butcher, I'm sure, was essentially you look at every problem from the outskirts of the universe, and you quickly focus it down onto what your real concern is. That's butchered, but the basic principle is that you need to be very open-minded in your engineering solutions. And one of the things that I always took away from Max Borders and frustrated me quite a lot when I came to the Middle East is this idea that there's a cookie cutter design solution for engineering, because almost to a fault at Max Borders, we were encouraged, if not pushed, to make sure that we found the absolute right engineering solution and not to just rinse and repeat what you'd done before.
Yeah.
Whereas certainly when I came out to the Middle East in that period of 2009-10, it's a lot better now, a lot better. But there was very much an idea that all you did was the same thing over and over again. The solution to every problem was fan core units. And actually you try and do anything else, and people got really, really concerned.
Yeah.
To this day, it's still really difficult to convince people to look at, radiant cooling. Robert, I know something that you're particularly interested in, chilled beams and things like that. There's absolutely no reason why that isn't a viable solution for lots of questions in this region. But even now, people are a little bit closed-minded to it. Whereas at Max Borders, it was very much the types of projects that we did. You couldn't have the same solution over and over again. I mean, one amazing example on the Tate Modern 2, and this just goes to show the flexibility that we were given at that business at the time. So we were working on the early stages of the Tate Modern 2, and we were looking to try and do whatever we could to reduce the energy consumption of the building from design. So there's a massive, great substation right next to the building, and we were looking at water cooling the transformers and using some of that heat. We were looking at boreholes and all sorts, and we were looking at it. And there's something in London called the River Terrace gravel. So obviously London is basically on London Bay. Then underneath that, you've got a whole load of really crappy, kind of shaly kind of stuff. And there's huge amounts of water. There's leakage from all of the water network. There's stormwater runoff. There's all the water that they pump out the tube. It's really nasty, crappy stuff that you can't do a lot with. But what we thought was, maybe we can do something with the heat, either take some heat out of it or put some heat into it. So, okay, that's a good idea. So we put together a concept of like a borehole, but instead of a deep well borehole, it's quite a shallow borehole just down into the River Terrace gravel, so maybe 20, 30 meters below the ground. We designed it, we got some specialists in, and they said, the client said to us, okay, let's do a trial of it. So we dug these boreholes in the grounds of the Tate Modern, turned it on, put it all in, set it to work, turned it on, everyone went away from the weekend. By the time we came in on Monday, phone starting to ring. It's like, well, yeah, there's a bit of a problem. Okay, what's that? We flooded part of the basement of the Tate Modern. Because what? Because it was an old power station. The core wall had so many holes through the wall, and we haven't thought that when you turn this re-injection borehole on, it lifts the water table. You get this dome around the re-injection borehole. It started putting water.
Oops.
But nobody got that angry about it, because it was like, well, we're trying something. They were given the opportunity to try different things to see if they could come up with a unique solution. And we learned a lot from it. And actually that solution was implemented after plugging up some of the retaining walls on the final project. But as I say, that they were given that rope to do things like that because of who they were, and they were capable of coming up with those sorts of ideas.
That is great, because this is why, having those special experiences in your career, like in North America, that would never happen, because the thought of a lawsuit and the insurance people would just lose their goddamn minds with what you just said. They would just be a hard no, right? Wouldn't even like, if you'd have floated down a meeting, you'd have been shut down so fast. You know what I mean? So that's the difference, right? The difference is, that's an engineer's solution, proper engineer's solution.
Yeah, I think one of the things that's can be a little bit frustrating in this part of the world, and in the UK, certainly within that part of the business, people trust the consultants and they trusted us as a team to make the right decisions and to do the right things. Sometimes it does feel a little bit like there can be a bit of a lack of trust in the team. which can be a little bit frustrating. You have to, again, I feel a lot of this stuff has got much better over the 16 years I've been here. And certainly in the last few years, there's a much greater acceptance of trying new and different things, because with the focus on, energy and building performance, there is an acceptance that you can't keep, giving the same answer to different questions over and over again. And that's a real positive. And, things like, there's a number of projects I've worked on out here with, radiant cooling and different cooling systems and different approaches that probably wouldn't have flown even 10 years ago, because there's more knowledge and skills, and the build quality is a lot better, which again was a bit of an issue out here for a while. Yeah. Still is in some cases.
Delicately handled. Very delicate.
I think the company was IDEA, and I think the guy's name was Steve Kelly. I could be getting this wrong. Anyways, so they're an industrial design firm. They helped Steve Jobs develop the mouse and the iPhone and all that type of stuff. And when they design a product using the principles of industrial design, like your colleagues, these people came from all walks of life. So they would have a client. The client came and said, "We want to build this widget, design this widget," and they would literally populate their design team with everybody. Like, it didn't matter what field they came from, like the astrophysicist or the janitor or whatever. And they would all sit down, and then they would design this product, and then they would put it back out into society to test it. And that was their whole principle, is that if we hired somebody that was, sort of focused, narrowed focus, we'd only get that solution. But if you expose that problem to multiple people, you get these creative ideas. And it's a wonderful story that, and I think 60 Minutes did a series on the relationship that the founder of this IDEA had with Steve Jobs, and that whole relationship about designing products. And, some of them work and some of them don't work. But until you get out and do the test drive on it, that's when you find out what the problems are. And you think about all the developments that have happened in the world of architecture and engineering. It's a pretty amazing field in and of itself, but it's not like there hasn't been problems.
Yeah, but what Nic is talking about here is difference between design and then just a copy and paste engineering solution, right?
Yeah.
So a lot of markets are skewed towards copy and paste, because if you get sued, you stand in court with the copy of the ASHRAE standards or the CIBSE standards, say, honest governor, I did what I said in here.
Yeah.
And you're bulletproof, right? The minute you deviate from some table in the ASHRAE guide, you're open, right? And so there's this like super incentive not to do anything new. This is why I sort of love firms like Max Fordham and that, who are just pushing that envelope out. Someone's got to do it, right?
Mm-hmm.
So I'm
it's like the guys, it's like the guys from TransSolar, Thomas Auer. Do you know Thomas? Adam, you must know Thomas, do you? Or
I know the name. I'm not sure I've met him actually. I know I'm aware of it. Who they are. Yeah.
Or Peter Rumsey. Like, there's two guys that they live on the edge.
I spoke to Peter recently. Peter Rumsey. Actually, I know Peter, but.
Yeah, but you're right. But so then there's a conflict right there. In terms of when you think about pre-manufactured systems and the solutions that pre-manufacturing provides, but is there creativity within the pre-manufacturing? I think we've talked about that actually before on the show, that, there's a lot of creativity that goes at least into the initial models that are made. And once you solve all those problems, then the cookie cutters come out and
this is a good way of setting the table for one of the things I want to speak to Nic about today. So there is, so for the audience, Nic heads up the MEP if you're American and the Building Services Department if you're British in AESG, right? So that is like the mechanical, electrical, plumbing, ICT, ELV design solution for a building, right? Or the embedded technology. Now, historically, in my career, that has been a low margin commodity business, driven mostly by copy and paste spreadsheet design. So why is Nic doing that? Well, one of the things ASG are trying to do here is sort of like elevate that design solution, make it a coordinated solution, right? Now, again, if you're a North American, this sounds a bit strange, but having the plumbing, electrical, everything all meshed in properly, the access control, the ICT, the ELV, all in, right? And then using digital tools that are sort of prevalent now, like Revit, BIM, things like that, just to really make it like an engineered solution, low errors, no omissions. Let's face it, the basic assumption in every contract is 0 errors and omissions, right? So, we live it. Our business is the only business where the designers design something. The client has a big bucket of money, and then every time there's a mistake, they go, "Oh, well, right, that didn't work out. Here's a change order," and the client goes, "Okay." If that was someone designing your kitchen, you'd lose your goddamn mind at that point, right? So what I want to talk about is, Nic, how do you see you can sort of elevate that to with the tools you're doing? What's your mission here? Let's start with that. How are you trying to redefine it?
Look, I think there's, as I say, so in my career, I've been lucky enough to work at both ends of the spectrum. I've been lucky enough to work on extremely bespoke, high technology, high complexity buildings. Natural History Museum is nearly complete in Abu Dhabi. It was a fantastic project in my career. UA Pavilion at Expo, and again, a lot of the stuff I did in the UK, Tate Modern 2, I worked on, and some other great projects as well. But I've also done a huge amount of what I always refer to as bread and butter projects, which for me, a typical one would be maybe a 40,000 square meter 50-story resi tower, which in Dubai is ubiquitous, and with those, it's a different challenge with those sorts of projects, because the technological solutions, it's very difficult to innovate, and to be honest, there's no need to innovate in those kind of jobs, really. The solutions are basically fine. Put a lot of heat recovery into your fresh air systems, right size your cooling systems, and again, this is a project where fan coil units is the right go-to, and you design your technical floors, and you design your 100-meter blocks up the building, and so on and so. But that doesn't mean there's not challenges in those kind of jobs, and it doesn't mean that you can't innovate on those kind of projects. It's just, for me, the innovation doesn't necessarily come from the technical solutions that you're putting in. It actually comes from how you're developing those technical solutions in the first place. Because it's such a competitive market, an extremely cost-driven, focused market, you win on price, typically, on those jobs. We have, in order for us to win that work and to make enough money to sustain ourselves as a business, we have to find ways of doing that stuff quicker and efficiently. And for me, there's a lot of the engineering we do within building services, which actually really isn't very difficult. When you look at pipe sizing, duct sizing, applying ASHRAE 62.1 calculations on an area basis, none of that is rocket science, really. And actually, a lot of it can be automated. And when I say automated, I'm not talking about generative AI or anything like that. I'm talking about simple routines, because a lot of the calculations are X times Y. And actually, what we can do and are doing with the Revit model is using it for what it's for, which isn't a 3D coordination tool. That's part of it, but it's not all of it. It's a repository of the building project information. So in that model, we have the areas, we have the space usages, we have the types of glazing, we have all of that information. And by going into that model, writing scripts in Dynamo and Python, we can pull out the information we need. We can drop it into our Excel spreadsheets, or using GBXML, take it into HAP or Trace or Train or any of these other tools, do all of our calculations, and then push that data back into the Revit model. And that's really, really powerful, because what you're doing is you're starting to cut down on human error. You're starting to cut down on time, and it's allowing you to be efficient. We're not doing anything different. It's the same workflow as an engineer would go through, except instead of looking at a drawing and measuring the size of a room and inputting it into Excel, it's simply pulling that information straight out of the model. And so if that information changes, the room gets bigger, smaller, whatever, you run your script again and it can update your calculations. So that's really powerful. And then you've got, actually processing that, you automatic scheduling and all of these kind of things. And that at the moment is pretty untapped. We are at the position, in my opinion, with Revit, that we can now produce models that physically represent the actual building to a very good degree. Almost all of I haven't worked on a non-Revit project for at least 7 years, probably more than that at this point, maybe 8 or so. From concept all the way through to IFC information. And we're now at the point where the expectation on the models we submit is that if you look at the ceiling, I'm looking at my ceiling here, the grills, the diffusers, the smoke detectors, the light fittings, they will all be in the location in the model that they will be in reality. So we're there. The next step is using the tool to not do our design, but assist us in working through our design and to really become more efficient. I think what really starts to get interesting is when we sort out all of this, and I believe that Revit, looking at the way they worked, or Autodesk and the way they worked, they're essentially using people writing Dynamo scripts and all of this stuff to beta test functionality that they are then going to bring into the tool and then sell back to the industry at some point in the not too distant future. Let's say we get through that process and we really do have a method of all of, whether it's IES, Amtech, all of these other software tools, we have an ecosystem that designs from and with the Revit model. When you start talking about generative AI and all of this, that's when I think it gets really exciting, because the reality is if you're laying out services in a ceiling, for example, let's again, typical residential projects, we've got a corridor, we've got apartments coming off it, we've got ductwork, pipework, electrical cables, a bit of cooling in the corridor, whatnot. Can you imagine a situation where you put in the basic parameters and then you go, okay, Mr. Chat MEP, give me the most optimized ceiling void that conforms to code in terms of the spatial arrangement, and it runs through 1,000 different iterations of locations of ductwork, pipework, and all of that kind of stuff, then spits out the most spatially efficient solution for a coordinated ceiling. I really don't see why that isn't going to be possible in a few years. You know what I mean? And that's when I think actually for standardized projects, I do think you could be in a situation where we are getting a lot of the work done by generative AI and automation, which is going to do one or two things depending on your mindset. It's either going to remove engineers from the picture, or it's going to allow engineers to actually do more interesting and complicated and useful things, like looking at strategy, energy optimization, and take their time and put it into areas that are more valuable, that isn't QA/QCing thousands upon thousands of duct sizing calculations or pipe sizing calculations, all of that, which again are not particularly difficult.
This is cool stuff. So do you see building codes in different countries being able to feed into those models in live time, so that the next time you do a project, the geometry for those spaces is now to the current code, rather than someone saying, okay, yeah, this doesn't meet code, or check the codes, but you'll actually have feedback from the building code developers that goes right into the model. Do you think that'll happen?
I don't see why not. I mean, again, if I look at some of the stuff in companies that I've worked for, tools that we've developed. So a great one, substation sizing. So in the UAE in particular, it is extremely code-driven. Particularly electrical design is extremely code-driven. The sizing of substations, in Dubai, it's different in Abu Dhabi, but in Dubai, the substations are owned by DEWA, who are the electrical authority. And is very, very prescriptive in terms of the size, the dimension, and the height above finished floor. Based on your load, that defines the size of your substation. So again, it's not very difficult to create an Excel spreadsheet where you say, okay, my load is X, so I need this many transformers. So based on code, this is the square meterage that I need. So again, you take that forward and you start pushing that data into Revit and say, okay, create me a box of this dimension with this louvers on these two sides, which is code compliant. Because again, all you're doing is applying rules. And if you as an engineer can apply rules and create a space, then you can write those rules into Dynamo or Python or some other software programming language to run those exact same rules, because it's not about opinion. Actually, for those kind of code-driven things, for me, it's easier because it's black and white. Where it gets challenging actually is when you've got decisions to make as an engineer. Do I have water-cooled chillers or air-cooled chillers? Do I go for splitting my load up in N+1, or all of those things which are a little bit more subjective. Straightforward code stuff. I mean, come on, you're applying a set of rules, and that's what programming and software does.
Yeah. I mean, I'm getting tingles on my skin. I think when I think about the power of data at that point, because,
Yes.
if you can get a feedback loop going with your data, then looking at AI, and when you start coming up with those solutions, AI could say, well, in buildings like this and these parts of the world that were designed using these strategies, these were the outcomes. And you could actually have AI do an assessment of those particular strategies and say, well, in your building in this part of the world, consider these choices.
But it's more powerful than that even, right? What you're talking about here is, I mean, there's so many ways to go with this, right? But as Nic says, there's engineering judgments and there's rules-based solutions, right? So the rules-based stuff, there's almost like this infinite database that could be developed, or this infinite cloud solution, right? Where all these rules are uploaded, they're crunched, then you draw from that. Yeah, you subscribe to a Revit provider, right? You draw from that, right? And then that leads you just to make the judgment calls, right? But the question is always data sovereignty, right? Who owns that? Is that our competitive advantage, or does that belong to the software provider, right? That's where it starts getting a bit.
It's hard to get the data as well. I won't go into details as to who, but one of the projects that part of the CIBSE technical committee were looking at was basically trying to look at the oversizing within mechanical systems. There's a general consensus that typically if engineers are going to get it wrong, they will get it wrong high in terms of estimating cooling load. Exactly as you say, for legal reasons. If you're going to, you're not going to get sued for oversizing something is a general rule. Yeah. So there's a real belief that we can do better in terms of application of diversity and right-sizing cooling systems. So we had a number of really good conversations with a major developer in the UAE and their technical team, and they were very keen to assist us in providing that data of their installed capacities, what they're actually, if they're connected to a DCP, let's say they've got 5 megawatts installed, but they only ever draw 3 or whatever that information may be. And it went really, really well up to a point. And then all of a sudden we got some feedback, no, this isn't happening. We talked about it with the high management and they're not prepared to share this data. Didn't hear any more. My suspicion would be is they've had a conversation that went something along the lines of, hang on a second, if we are oversizing all of our information, that means we're paying higher connection charges to our district cooling providers, which we're passing on to our tenants. Our buildings are also more expensive than they otherwise would need to be because we're oversizing things, which we're passing on to our onto the owners. And they just went, no, that's it. So all of this information is absolutely there. It's really hard to get it. There isn't really a mechanism, and people are quite protective about sharing some of that stuff, which is really tricky and such a shame because, could you imagine how powerful it would be to actually know
Absolutely.
what the diversity is on a residential tower for a cooling system?
And the ability to do forecasting and models that what happens when changes of climate occur that have consequences. What are if there is diversity and there's room in that space, well, where will that room take you? Up to what level, right? So you can start establishing limits, and that's hugely powerful.
But imagine that. Just take the diversity thing, right? So there's a calculated diversity, or an assumed one, and then there's an actual. And if there are big gaps between that, all of a sudden the client starts going, "What am I paying you for? You're a freaking designer. Why is this gap so goddamn huge?" Right?
Well, but in absence of analyzing the data, you go back to your defaults. It's the data that comes back that allows you to make judgment calls and allow you to, and then you have way better what if models.
Yeah.
And I'm just shaking my head at that. That's
linking to areas of safety a lot of the time, literally to areas of safety when it comes to this kind of thing. The number of times my teams or other teams look at technical reviews and say, well, what diversity have you applied? 80%. Why?
Yeah.
So, and you're trying to explain to someone that diversity isn't something you apply, it's something that you calculate, and it's an answer you get, and you get this kind of blank look on the face. It's like, well, how did you get to an 80% diversity? So, no, I didn't get to it. I've applied an 80% diversity. Like, oh, okay. I'm not going to have to explain to you what diversity means, so we're going to be here for quite a while. But it as I say, it's endemic. Again, we've kind of got off the original topic, but it is a bit of a pet subject of mine. I did a big project in Abu Dhabi, big cultural project, and actually myself and the client did a massive exercise with my team and his team to look at the diversity and the loads on the building. We eventually got down to, I think it was something like 55. So the installed capacity was 55% of our calculated peak load, and both of us were like, when we were almost looking at each other going, "You all right with this?" Like, yeah, okay, all right with this. Genuinely, we knew what we were doing was a long way away from what would be standard practice. Like, we believed in the engineering. We were really good. Everyone had done a really proper job, calculations, assessment on occupancy, how the building was going to use. We were really confident in what we were done. But even then, because of what's been drilled into us, doing this for 20 odd years, we're like, Jesus. I was thinking through, if we are wrong, we are in trouble.
The Edifice Complex will continue in just a moment.
Are you struggling with paperwork, spreadsheet overload, and project management? Then Blue Rhythm is the solution to help you. Streamline your commissioning and project management process. Go paperless, increase efficiency, and save money. Blue Rhythm is commissioning and project management software by practitioners for practitioners, adapting to your workflows and processes, and doing things your way. Blue Rhythm provides painless and fast onboarding by bringing your existing workflows, forms, checklists, and issues logs into Blue Rhythm for you. You can use their pre-built templates to customize your commissioning workflows. And Blue Rhythm can fully handle the transition from your current software platform. Blue Rhythm is secure, scalable, and reliable, backed by amazing support, and accessible 24/7 on any Windows, iOS, or Android device. Why are you still using paper and hard-to-control spreadsheets? Start your free Blue Rhythm account today at bluerhythm.com.
And now, back to the show.
As performance data becomes more visible and ubiquitous, right? At some point, clients are going to go, hang on a minute. Why is every cooling coil here oversized? The control valve's in the flow, not the return. There's no authority over that valve. It's just going on, off, right? Just scale that up over 1,000 coils. Where's the efficiency gone there, right? So my theory is, as this all becomes visible, because in the past, you had to be one of us to know that was not right? But, as this becomes visible to the FM team and the client team, at some point, my view is someone is going to get sued out, a big firm is going to get sued out of existence, and that's going to set a precedent, and everyone's going to start behaving, right? But it's the old thing. There has to be a public execution before there's a change. Do you know what I mean?
Yeah.
I don't see any other way how this ends.
Yeah.
Those issues, though, they don't get seen for so long after, do they? That's part of the problem. That it's only, again, there's another example of a major hotel that, in the UAE, with the spare capacity on their system is insane. And it wasn't intended to be there, but then, they've got we've got, I think, 15 megawatts of cooling capacity in an ETS room out here we're not using. What? But they've signed up for a contract with a district cooling provider that they can't get out of. So they're paying this capacity. And it's like, how's this happened? Oh, yeah, the system was just oversized. But blimey, you could build two more.
Low delta T problem, right? The low delta T problem. I mean, I looked at a shopping mall in Dubai, shall be nameless. They had this bank of chillers, like half of them had never run in the life of the fucking building.
Yeah.
Just sitting there.
But there is a huge joy that comes to any engineer where I love that conversation you just said there, Nic, about sitting eye to eye across your client, and you've done the numbers and you trust in the numbers, but you're questioning your assumptions, and then you're going, are you sure? But I remember, and Adam, maybe I've told the story before, and I'm getting old, people, so I might have told the story several times, but forgive me. But I was in Arizona, and back home here in Calgary, it was like minus 36 Celsius or minus 40 Celsius, which is the same at minus 40. It's the same number. And I had a client call up, and we had designed this underfloor heating system for this large multi-purpose industrial building. And Andy was his name. And Andy called me down in Arizona. He said, Robert, building's running great. Our supply temperature is at your design 110, but we want to drop the temperature. I thought, I love it. Yes, Andy, drop the temperature. Let's see what happens to 100 Fahrenheit. What is that in Celsius? Anyways, at minus 40 degrees Fahrenheit, when a client calls up and says we want to drop the temperature, not increase it, then you're going, yes.
Nothing wrong with that.
Right. And I mean, the boilers are already probably hitting, 93, 94% efficiency because of the return temperatures. And by dropping the supply, like wherever that boiler, whoever designed that boiler or boilers, they were just doing a happy dance because the system was doing exactly what that machine could do because somebody did the numbers. And, those are the joys that you get when
Yeah, that's called engineering, not copy and paste.
That's why they call it engineering. Yeah.
But again, again, that example I was talking about, it was on the signature project with the signature client, and we had the fee and therefore the time to really invest in the technical side of it. And when we talk about a lot of the other projects, which are cookie cutter, or the bread and butter type of projects I was talking about earlier, unfortunately, a lot of time, because you are really pushed for time, you really are pushed for fee, you have to find a way of getting, don't let perfect be the enemy of good. It's got to be functional, but you can't afford to really get too far beyond the norm and that's where I think actually you need to kind of find ways of optimizing your processes to allow you the opportunity to kind of really look into the areas of interest and the area of complexity, because otherwise you have no other option apart from just going, okay, well, with the fee that we've got, all we can do is turn the handle and pop out the same building as we did last time with a different face on it, which is, again, is that engineering? Maybe yes, maybe no.
Hey, here's a question for both of you guys. In terms of you've got these high sophisticated modeling tools and I'm struggling for the words, but it's the learning cost, the parasitic learning cost of your design teams to learn the tools and work out all the bugs. Are engineering firms and architectural firms around the world, are they getting compensated for that learning experience? And right? And so, I mean, who's winning here in this game? It's the software developers, and everybody that uses it becomes the guinea pigs, but there's no compensation for that at all. How do you rationalize that from a business point of view?
You've got to see the direction of travel of the industry, and you can try and swim against the tide, or you can accept where you're going to end up and try and figure out how to get there before anyone else. There are a lot of these tools are complicated. The level of work that's involved in producing a genuinely coordinated Revit model with good levels of data embedded, federated models, COBie data, all of that stuff. It's a high bar to get to. It makes the product better and it's useful. The trick is to, if all of your competition is being asked to do the same thing, how do you deliver that quicker and better than anybody else? And again, a great example, I think I touched on it earlier, coordination of ceilings, right? There is a disconnect in a CAD world. So when I first started, the MEP drawings would show grills, diffusers, lighting, whatnot. If you overlaid them all onto one drawing, they'd be a bit all over the place. But the ID guys would come in, they would do their own drawings and they would set everything out and they'd tidy it all up. And those two things, they existed in parallel. They were sort of the same, but they weren't the same. Now, in Revit, we've got one source of truth, which is the model. So if an ID consultant wants everything on a center line and they want 200 mil separation or 150 mil separation, or they want everything to the left or want everything to the right, the only person realistically that can put those components into the model in that location is the MEP consultant. So that creates an issue in that effectively the MEP team is now responsible for something that used to be the ID team's job. We're not getting paid any more for doing that work. Right. And all the ID team now are doing is they're taking the Revit model and they're exporting the RCPs, which includes the MEP components. So we're now effectively producing some of the RCPs. So long story short, when we were looking at this a couple of years ago, we basically had two options. One, you can either say the status quo is this is not the responsibility of the MEP team, so we're not going to do it. So we figure out another way. It's not us going. What we did and what I continue to do is to say, well, actually, look, if you look at our direction of travel, it is going to be a fully coordinated Revit model where literally everything you see in the model is representative of what it's going to be in reality. So if that's where we're going to go to at some point, whether it's this year, next year, or further down the line, instead of fighting it, let's figure out how to do it quicker, and let's figure out a workflow that we can use with ID teams to get us there without any. So we sat down, tried loads of different things, and we basically ended up saying, listen, we will coordinate every visible component, every socket, every smoke detector, all of that, exactly as you want it in the model. But there's a condition. We have to start doing this at the start of detailed design at the latest, ideally in schematic design. You can't have your ID team starting a couple of stages later. We need to agree everything in CAD, set it all out, get those RCPs frozen. Once you've done that, then we start modeling. We're not going to model, if we've got a grill, we're not going to model the connection from that grill back to the main duct until you tell me the RCPs are signed off and the access panels are signed off, because if you move an access panel and I have to move a fan coil unit, it completely kills all my coordination and we have to start the whole thing again. So we figured a way of doing it. We changed our workflow and we changed our process. And now we can give the client what they want, provided everyone understands what we're trying to achieve and they play ball. So again, it is more complicated and it is a new challenge. But as I say, for me, you just need to look at where the tide is taking us and figure out how to deal with it. You can't stand there shouting at the tide. It just doesn't work.
Right.
Yes, King Canute.
I'm going to use that.
Okay, that's interesting. So one thing I do want to touch on is errors and omissions. So when I became Frotty developer and my bonus was tied to the contingency fund on my project, and then the MEP guy kept coming and going, oh, sorry about that. Can you sign this change order? I started focusing on errors and omissions. And I was, until the point I'd made that flip, I thought engineers were good. We didn't make too many mistakes, but it turns out we did. And the errors and omissions rate horrified me. Some of the big firms who shall be nameless, who worked on some of our jobs, were terrible. And there was no shame in it either. There was no, oh, sorry about that. It was no, just sign this, please. Thank you. I'm out of it. So I started sort of focusing on it. Now, with all the digital tools we're talking about here, with these very refined Revit models, does that take the errors and omission rate right down?
Oh, I mean, in theory, yes. I think when you start data, if you won't, there's a couple of things that have always frustrated me about the way that we worked, and now I'm sort of beginning to see a route through to solving them. So one classic example is drawings, schedules, and schematics.
Yeah.
3 intrinsically interlinked pieces of information, which up until very recently had zero link apart from a human and a markup and an Excel spreadsheet. Do you know what I mean? Because you'd have a drawing, which would have some numbers on it, and then they would, even calculations to drawings, to schematics, to schedules. All of that information got taken in by a person and then regurgitated out into the next package, the schematics and the schedules. And a number of times you'd be QA/QCing something and you're looking and go, hang on a minute, this number is different here, 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 and here. Or you'd have a schematic and you'd add up all the numbers down a horizon. None of these numbers add up in the way that they're supposed to. We are in a position now where those kind of things can be very much smoothed out. Scheduling from Revit is a great example.
Yeah.
If you're simply taking an audit of your Revit model and say, okay, how many fan coil units, how many distribution boards, stick them in a schedule. There is no human error in terms of the count. There is no human error in terms of the referencing, because it's the same data source. So absolutely, that's going to improve things. The other thing that I think is changing with the Revit world, which is very good, and again, I'll be interested to get your guys' take on this. When I started at Max Fordham, we didn't really have a CAD team per se. There was a CAD team, but they had a particular role, cleaning up architectural backgrounds, XREFs, doing all of that kind of side of things. But they didn't produce our drawings for us. We as engineers did our own CAD work. So I was a bit confused when I came to the Middle East and they said, oh, you do your markup and you hand it to the BIM team, to the CAD team. Really? That seemed a bit weird, but surely that's my job, isn't it? But what we've seen as Revit started to come into the picture, there's been a massive disconnect between engineers and BIM technicians, because the engineers who are, in my 40s now, the people of my era a lot of them do not know how to use Revit. And therefore, it's very difficult for them to kind of get into the tools and to actually make the changes. The newer generation of engineers that we're seeing come through are kind of Revit capable from birth, if you know what I mean. And actually,
love that.
We're losing this thing of doing a hand-drawn markup or doing a CAD markup and then handing it over to the BIM team. They reflect it in the Revit model, then hand back a drawing to QA/QC, which is wildly inefficient and creates all of these potential human error routes all the way through the process. So I think because BIM Revit is becoming so intrinsic in what we're doing, we're cutting out a couple of steps, which again I think is going to improve the quality, because essentially the engineer will be doing his modeling, which I think is going to cut out a lot of mistakes on that side. So long story short, yes, I think it is getting better and will continue to get better.
Yeah, I mean, that's, again, old as hell, right? Schematics, everything begins and ends with a schematic for me. And when I went to North America and I started asking for schematics, we don't do that here. Like, it's a different culture. So this is where engineering culture comes in. But a schematic with all the numbers on, relevant numbers on, is colored as well.
Yeah,
that is the most useful bit of information you could ever ask for if you're trying to commission a project, right? So I love the fact that can be spit out easily and quickly. So this is where Revit becomes powerful. Right?
It's got better, but that is still a little bit tricky sometimes. Drawing plans to schematics there are ways of doing it, but it's not as smooth as you might think it is. But it is getting better. But certainly drawings to schedules and things is pretty locked in now.
I used to do a lot of work with the Corps of Engineers. They always used to do, as part of their package, a schematic of the building showing like the balance of supply and exhaust, and the whole thing. And it was just these schedules and drawings, and it was just such good information for me when I was coming in at the end and I had to like learn quick what was going on, And they were also using it as a way of like doing a final check on building pressurization. Is everything there? Have I missed anything? They were very good at being consistent.
Yeah, and there's some stuff you can do. Because again, if you've set everything up right and all of your data's there. So let's say, and this is quite an interesting one. So I was working on a project, and we'd done all our ESP calcs for a smoke ventilation system, and the ESP on the fan was massive, way higher than we would expect it to be. We just couldn't figure out why. So what we got our guys to do is we got them to take the ductwork and all of the flow rates, everything was built into the model, because that's the way we'd set it up. So we extracted the isometric of that fan system. And we just said, right, just apply a color filter on duct pressure drop per meter and velocity for the whole system. What we found is there was a length of duct where, for coordination reasons, the BIM team had basically said, okay, we've got a big pipe coming underneath it, so we need to squeeze the duct.
So
the slab was fixing the top point, so they just brought it up. And there was a length of duct about 15 meters on a massive great system. Huge, great velocities, and there was, a couple of 100 pascals within about 30 meters of duct, because they just squeezed it.
Why is the concrete cracking at that?
we hadn't picked up in the calculations, but pulling it out of Revit and color coding it, there was this big flashing red bit on our ductwork. We were going, bloody hell, it's just like 30 meters. What's going on there? And and that allowed us to go in and solve that problem that we couldn't quite figure out beforehand. So again,
that's a great tool. What a great diagnostic tool that is as a design check. Holy crap.
Because no one would have changed the hanger systems for the velocity going through that duct, the vibrations, right? They would have just kept it for the same stuff. Hey, this is fascinating stuff. We keep talking about this. Tell me, how do the vendors react to these models? Because you put all these models together and having to go, so you get someone comes and says, well, we can provide a chiller for less money than that. Now you got to go back and you got to look at the geometry of the mechanical rooms or whatever that is. So how do the vendors approach this whole modeling world when you've done all that work and then now they're asking you to maybe change some of it?
Look, typically, because it hasn't changed our approach to selecting equipment or doing designs in that, we work on vendor neutral specifications. So we're typically working to 3 to 5, top tier suppliers. And so what we would normally, chillers is always really tricky as a specific example, particularly, air cooled and water cooled chillers, because different manufacturers, the geometries can be wildly different. So maybe that's not the best. That is a good example, actually, because in that case, I think you do need to sort of set some parameters for what you're basing your design on, because you can be in this. And actually, I have been in a situation where we had a really tight plant room for water cooled chillers, and there were only 2 manufacturers that could spatially work within the confines of the plant room. And what we said is, look, all of these manufacturers are able to price this project. However, one of the constraints is the physical dimension. You need to be able to achieve these particular sizes and work within that plant room. So, I don't think it necessarily changes your approach at all. For something like a fan coil unit or a radiator, if you've got a standard family, that's just fine. You don't need to worry about it. But I don't think it necessarily changes your approach to the bigger stuff. You can't necessarily design for absolutely everything, and you need to understand what you base your design on and what the limitations are. Some things just might not necessarily work in the space you've got.
Yeah. So really, I guess the onus is on the manufacturers to work with whatever constraints are on the project, and you either have the product or you don't. It's
exactly.
Yeah.
And that's no difference whether you're doing it hand drawn or whether you're doing it with Revit, to be honest with you.
Yeah.
So this is one of the limitations of Revit. There is a steep learning curve. It's expensive, right? And until the whole supply chain from like design engineer to contractor to vendor is using it and using the data out of it, the common model, it's hard, right? Because someone's going to break that chain and go, I've done a takeoff and the box is this size and I can get my bit of kit in it, and it's probably lying. And then off you go, right? So I think that's one of the big constraints is the cost and the complexity. And that means, again, I remember when, old as hell, right? CAD came in and the early CAD technicians made lots of money, and then slowly but surely it moved from the design community, designers to the contractors, and then everyone was using it, right? And there was that moment where the whole chain were using it and it worked. I think that breakthrough is yet to come for Revit, I'd say.
Mm-hmm. It's one of those things. It's there in patches.
Yeah.
We're doing a lot of stuff with a big developer in Abu Dhabi on some of their existing assets, and on some of the assets we've got proper as-built LOD 500 models, and honestly, it's an absolute it's a joy because the guys are on site. They're coming back with photos. We're looking at the model. We go, it's almost. It's not identical, but it's pretty bloody close. And then you've got, other assets that are maybe 3 or 4 years older. And so, well, have you got any as-builds? Like, no, we basically, it was on Aconex or some other file system.
They turned it off.
And it's just gone. And the power of having that information is amazing. And obviously, Adam, as you know, we do a lot of stuff with digital handover. And actually, when you start layering on not just the model, but also the O&M manuals, the maintenance stuff, and you have that LOD 500 model becomes a repository for everything to do with the project and all the products. It becomes incredibly powerful. But I always it's the BMW sort of 5 series of buildings that have that, and in time all of the technology that you see in the BMW 5 series, eventually it filters down to your Toyota Corolla, and I don't think we've filtered all the way down yet, but it will happen in the fullness of time, I'm sure.
Yeah. Are the tools at a place now where they can identify maintenance conflicts? If you think in terms of when you get into a crammed corridor, piping, electrical, all of that, there's some equipment that needs access, distances, right, to be able to pull stuff out or maintenance. Are the tools, the Revit tools, the BIM tools, are they able to identify those conflicts?
Basically, there's a number of different kind of standards in inverted commas, and one of them is LOD, so level of detail, level of design, so 100, 200, 300, 400, up to 500. And that mandates what you need to show in the Revit model. And that includes things like, space for access. So if you look at your even early stage space planning, let's take a fresh air handling unit, for example, you should have the box for the unit, which shows the basic physical dimensions of it. And then there should be another kind of transparent box that's next to it that shows the coil layout. So, right from the very, very early stages of your space planning, you should be looking at maintenance and access. Now, what you'll often see is that that's applied to things like fresh air handling units, and you can obviously look at access paths and routes through plant rooms and things like that. Where it gets a little bit iffy and it tends not to be done is, let's say you've got a valve package in a ceiling and the ceiling's very
that's where I'm going with it. Yeah,
it's not at that level's probably not there. There's no reason why you couldn't, to be totally honest, because all you do is create a box, and that box would have a parameter, and you would clash detect that box with other things. So you say, is there anything entering the area of my access zone, for example? And so it's possible, but it's probably not ubiquitous.
Yeah, I was imagining someone having to work on a scissor lift or a ladder up in a ceiling space trying to do a service work on an actuator, right? And, that's just, but if that could be identified in advance, then that just makes someone's life a lot.
Well, this is where the FM team start working with these models. That creates that demand almost, right? But we're coming up on time, but one thing I do want to talk about quickly, which is another bête noire for me, is control sequences of operations, right? You design and select all the equipment you want. There's a sequence of operation that goes with that for startup, close down, energy efficiency, cooling, breathe, recovery, all that. So how do you deal with that in your Revit models? Do you incorporate those in, or are they part of the schedule, or what?
So I love a good. God, I'm so boring. I have a good sequence of operation. I think sometimes they're very poorly defined. And actually, I think the way I like to see the control sequences is something written down in words. I think you need to be able to explain in words what it's doing under different circumstances. And I've never seen a point schematic or a diagram that represents it as clearly as if you sat someone down and said, tell me how this is supposed to work, and then they enunciate it back to you. So the way certainly in this region that BMS and all of those kind of things are dealt with is you have a system architecture, which is obviously typically it's your IP backbone through the building, and then your DDCs, and then all the equipment that connects to it. Then you would have your control schematics, your point schematics. So, it would be a block diagram with your temperature sensors, your VFDs, all of that, your AIOD points and all of that. And then I would support it with a written section within the specification, which described in words what it's supposed to be doing under different circumstances. I'm not aware of how that potentially could be linked to the Revit model. The closest we've got is we're now starting, which is not something I've really seen too much before, is actually produce BMS drawings in our design phase, because it's quite easy now. We can literally just say, okay, we're going to select all the fan core units, all of the dampers, and just pull them onto a drawing and say, right, so all of this stuff is controlled in this DDC located here. So we're trying to elevate what would be a normal basic kind of contractor design portion, but actually building those sequences into the Revit model, not so much. Potentially you get that a little bit with like IES and things like that in terms of HVAC controls. You can do a lot to road test and validate control sequences in IES. But
I've only ever seen two organizations do this well. Arup used to do it well. They would have that whole written sequence and a points schedule, and it would be a separate spec section, and it was normally very weighty, and they would not let any job go out that didn't have that, and I respected the hell out of that. And the other one was US Corps of Engineers. They would always produce a drawing with a schematic and a point schedule and a written sequence. So every system, I would have this fucking A2 drawing. Oh, right, that's everything I needed, including the interfaces with the fire alarm, which was awesome for me, right? So, it was just clear communication. And from a design point of view, it's a checkpoint, right? Is it all there? Have I missed anything?
It's one of the most valuable tools and exercises to go through is to write a sequence, because it forces you to go back to your design and look at all the if-then statements. If then, and then it identifies the conflicts. It makes you actually some cases go back and look at your load calculations. It's a hugely valuable exercise, no doubt about it.
Yeah. Yeah, there's one of the things I quite like doing in obviously UAE, really, really hot, really humid. But you do get times when it's not very humid here, so you can do supply air temperature reset on fresh air handling units. Yeah. And so I wrote this sequence. I thought, I really like that. That's really clever. That's really good. Now I suddenly thought, hang on a minute. How am I going to? Because we've got a sensible wheel, then we've got our coil, then we've got our enthalpy wheel, coil, sensible wheel. So I was like, the only way this is going to work is I need to know my enthalpy after my enthalpy wheel, because that's going to be driving the decisions I make afterwards. So I was like, I don't have that in my drawings. I was like, I need to make sure that sensor is there, because otherwise the sequence is pointless, because you can't do the thing that I want it to do without that piece of information. So yeah, I totally agree. It does force you to have a good think through what you're doing and why. I think sometimes engineers do without thinking why.
Just that review on sensor locations. There was a firm I worked at, she'll be nameless, used to do what they called Shark Tank Fridays. So design team would put a drawing up and then they'd invite people in just to shit on it, to try and make sure, right? And I would be pulled in as a commissioning guy. They say, tell me what's missing on the sensor front. And I go, we need, so that was their QA, QC, right? But there was always a sensor missing. Without fail, there was some sensor not there. Do you know what I mean? And just that one $50, $100 sensor would determine the efficiency of that system, right? You design all you like. If that sensor's in the wrong place and it's not driving an efficiency that you've assumed, what we do here, right? I don't know. Anyway, ranting like an old man, which is my job description.
I think one of the things that I learned towards the end of my career, and I wish I had learned it earlier on, was that I always started a project. At the end of my career, I started the project actually with standardized controls, and I designed it around the catalog of controls.
Yeah.
Before that, I would custom design systems, and then I would have to go to control vendors and go, okay, can you make this shit work? Right? And so it became costly and expensive, and relays and drives, and it just became it was terrible. But when I said, okay, you know what, ultimately the driver of this entire system is a control package, so let's start with what's off the shelf, what's proven stuff, and we're going to design our mechanicals around it. And that just changed our systems for sure. I don't know where you guys stand on that, but
No, look, every system and its effectiveness and efficiency comes down to $250 sensor somewhere, right? And I call that the optimum point of performance.
Yeah.
So we are coming up on time. So we normally finish with a couple of quick fire questions. So I guess I'll start. MEP design, good career choice or bad career choice? What do you think?
Got a quick question. I love driving past buildings that I've worked on and knowing that I had a big part of it. And I don't know that there's many jobs where you get to do that. So for that alone, yes.
I agree, 100%. I'm a bit like that.
I'm not sure I would make the same choice again, knowing what I know now, though. But
yeah, thank you. That's exactly how I feel. Yeah.
So Nic, let's just say you're talking to a new graduate who, has this opportunity to go abroad to practice. How do you help them get over the apprehension and the hesitation about going and just take that chance and go? What do you say to them?
No, what is the worst that could happen? That's how I make all of my important decisions. If this goes as bad as I could imagine it, where am I? And if it is, well, in 6 months, I'm coming home again.
Yeah, that's a great.
Would you rather be in that situation and have gone and tried it than never have tried at all? That's how I approached it. And I'd say 16 years later, I'm still here.
Yeah.
Exactly.
That's a great.
I mean, I don't know you, Nic. Every time I go back to the UK, I think, oh, I'm so glad I don't live here. All right, man. That's good. So look, keep doing what you're doing, man. You're doing God's own work. Someone needs to move the needle on MEP design and take it up a notch, right? And I think you're doing good work there, mate. So keep that up.
Thank you very much. Yeah, thank you. Yeah. It's been really fun. I've really enjoyed this. So thanks a lot, guys. Appreciate it.
Yeah, thanks for coming on, Nic. It was great.
Thank you.
The Edifice Complex will continue in just a moment.
Are you passionate about the built environment? Do you want to learn from the industry's most inspiring, intelligent, and accomplished professionals? Then the companion to this podcast, Wisdom of the Property Crowd, is just the book for you. From Edifice Complex podcast interviews, this book distills the critical thinking, insight, and ideas of some of the property industry's most accomplished and respected practitioners. Each chapter is a synopsis of an hour-plus interview, capturing the takeaways and insights, including diagrams and images to help explain concepts and ideas. There's also a brief bio about the interviewee and a QR code linked to the podcast episode for those that want to explore further. These are the mentors you wish you had in college. Wisdom of the Property Crowd by Adam Muggleton. Available on Amazon worldwide.
And now, back to the show.
Adam, it was great having Nic on. That was awesome. His responses to our questions were really good. And again, like for kids in school, like kids and young adults, if you get an opportunity, what is the worst case, or what's the worst thing that can happen?
Exactly.
And if you can live with that, then yeah, take the chance.
Think about it, right? So I know Nic, I really respect him. He is what I call a proper engineer. He really knows what he's doing, right? He can think like deeply and adjacently. He's got that ability to do the macro and the micro. That's an unusual trait. But he didn't have a plan to be a chartered engineer. He had no idea where he was going to work. He didn't know he was going to be an expat. These things happen. But the point is, he took them when they arose, right? Yeah. So these opportunities come up and he took the opportunity, right?
Yeah.
There's a job at Max Fordham. What's that? I don't know, I'll go.
Fear,
Yeah.
fear, apprehension, anxiety, all of those things that prevent you from taking chances that can change your life. You got to learn to, and when you're young, it's hard to do that because you don't have the experience yet. When you get older, you've had so many moments of fear, you just don't care anymore.
you just you look at it and go, oh, I see you.
Yeah. And and then if you're lucky enough, you get to be like us. When fear faces you in the face, you just tell it to piss off.
Exactly. Yeah. But just think about it, right? So he's had a great career and he's having a great career, right? But he took the opportunities. But I love what you said about becoming an expat, right? So the ideal thing is you have the sort of career Nic had where you, by pure luck, and it is luck, you wind up at a great firm. Now, he wound up at a very storied firm, MEP Fordham Partners, which is one of the great firms, right? And they had the real emphasis on recruiting people with potential and then just banging into them what they needed to have banged into them, right?
Yeah.
So that was luck, but he did it. He went through it, and he got it done. And then he became an expat. And I love what he said about being an expat. It reminds me of when I became an expat. So first, I had a friend, there's a long story short, right? I had a friend in the mid-'80s. He got a job in Saudi Arabia. And we were all sitting around one day in a cafe. And I said, look, if something comes up, call me. I'd really be interested in that. And everyone on the table said the same thing, right? So 4 months later, I'm having dinner at home on a Sunday night. Phone rings. It says, Lawrence from Saudi Arabia, do you want to come? I said yes. The other people said no because they didn't have the balls to do it. Now, I was scared. I'll be honest with you. I was scared. I'd never been further than Spain at this point, right? Which is a 2-hour flight from London. So I went. I was bricking it. But it turned out to be, it was a life-changing decision for me. But of the 5 of us that said, call me, he called 5, 1 went, right? Yeah. And that's what Nic was saying. Go. What's the worst thing that can happen? This is what I said to myself. If I don't like it, I'll just come home, right? Yeah, it'd be a loss of face, but what the hell, right? And when I got there and it was tough, I thought, I can't go home. The loss of face would be horrible, so I got to tough this out. But I toughed it out, and it was great. It turned out to be a fantastic experience, but it took me 2 or 3 months to sort of get into the groove. But what he was saying there is just take that chance. If it don't work out, what's the worst that happens? You go back.
Yeah. And again, like in the mentors, like if there's anything that, parents and these young adults in school can get out of our podcast is that mentorship is a gift. When that comes to you and to be able to recognize that someone wants to mentor you, for whatever reason, it's your personality, it's your drive. There's just something in your character that someone says that person needs somebody to mentor them because they've got a lot of potential. And if that's you and that faces that comes across your table, man, just embrace it.
That's what I said to my daughter when she did mechanical engineering. I said, the best thing that can happen to you is you're going to meet a miserable old guy who's going to sort of treat you bad, but treat you tough and learn your stuff.
Yeah.
You'll hate it, but it'd be the best thing that could ever happen to you. And I had that. But let's give a shout out to Nick's, the guy who sort of like mentored him in UAE, Peter Cummins, right? So Peter clearly, so just so you understand, when Nick arrived in UAE in 2008, that was like the financial crisis. I was going backwards and forwards on a project from Canada to the UAE at that time. And literally 1 month I went there, it was like boomtown. 2 months later, I went there, every single job site was shut.
Wow.
In the UAE, when things go south, they literally just shut the doors and stop paying people. He arrived into that. And Peter saw something in him that made him fire all the other people except Nick, right?
Yeah.
I'd love to know what that was. Maybe it was like, because, you see things overtly and subconsciously. It's probably the subconscious thing. I mean, when I met Nick and I had a conversation, I thought, oh, this guy knows what he's doing, right? But that's just because I'm old and I've met a lot of bullshitters, right?
Yeah.
But
I think given that, we know a lot of amazing engineers and architects. A lot of them are prima donnas, and they just become so difficult to work with.
Yeah.
But a guy like Nick, he just seems like he has such a wide diversity in gears.
Yeah.
He can work 6th speed or he can put them into 1st speed. But he just seems like he's got that personality that can manage all of the speeds that he's got on his gearbox, but he does it in a way it's just okay. He's part of the team. We can't let this guy go.
Well, the other key point he sort of landed on that he has, that a lot of engineers don't have, is the ability to communicate. You can lose your client when you start regurgitating technical stuff to him, trying to show him how clever you are, right?
Yep.
That is, communication is one of the key advantages you can have as an engineer, right? Because you're communicating difficult stuff that not many people understand. You've got to find a way to get that message across without looking like a knob.
And I struggle with that. Myself, it's a fine balance. It really is. And identifying your audience. And I've had two extremes, where I'll be having a conversation with somebody, and often this times actually happens online, and you introduce the subject matter, and by its very nature, you attract sort of a higher level of knowledge.
Yeah. Just
because of the subject matter. And there was one particular post we were dealing with, and I can't remember what it was. Anyways, it was an amazing discussion. I had 20 or 30 high-level thinkers that were in the post, and we had great dialogue going on. And then this guy enters the room and starts to complain that he can't understand what's going on. I had to remind him, listen, you walked into the lion's den. I didn't come to your den. You came to my den. And I'm sorry, if you're not following it, but this is, it's a master class.
And he's in my house. You're in my house.
Right? So, but I valued his comment. He basically said, if you want us to understand and apply this, you're going to have to drop the level down. And I said, fair enough, but this dialogue is a master class, and you walked into it. So, sorry, bud, but
exactly,
But now, if I was asked to go into an audience that was not at that level, well, then you drop it down. But that ability to be able to go up and down with your communication is huge. I totally agree with that. And I'm not always perfect when I do it, but I try my best.
It comes with experience and age as well, right? Because when you're young, you're always trying to prove how clever you are, so people assume you're not stupid, right? That's normally the default assumption.
I love this about Matt. What do you say? It was engineering hippie commune.
Oh, I love that.
Max
Fordham. Max Fordham was an engineer in hippie.
I've never
commune.
heard that before. One of the things that came to my mind when he was talking about, and it was really good when he was talking about the one client where they we're, across the table looking at each other in the eye and go, okay, well, we're going to do this. And what came to my mind was trust the numbers, question your assumptions.
Yes, yeah, that's a good point, actually. Yeah. So he was talking about a 55% diversity rate. Once it drops below 70, I start thinking, oh. Are we doing? I'm going to start a bit nervous as a client at 55, 70.
Yeah. How much manual operation do you want to do in this?
Yeah.
But and that's true. I mean, when you think about like the design work, the numbers always work. I've always trusted the numbers.
Yeah.
But it's the assumption behind the numbers. And I think that's one of the things about a skilled engineer is that you can look at the outcomes of a calculation and go, wait a minute.
Yeah.
Like your math is right, but what are the input values?
Yeah.
What are the input values, right? And then you can take them back. And those are learning experiences, right? With young engineers, when you get them to do the calculations and then you can point, say, okay, there's that number. Like, I'm not challenging how you got to that number, but that number needs to be looked at. So let's go back to the beginning. And it's like when Nick was talking about that, the BIM operator squished that duck, and they had that huge static pressure.
I love that diagnostic of just like coloring up that that section. But the other thing to say is that people, if you're young looking at it, you think, oh God, he must be just a savant. He must work all the time. Let me tell you, I know Nick. He goes home on time. He has a wife and kids. He's present as a father. He's a black belt in jiu-jitsu, right? He has a life, not just work, right?
Yeah.
Because one of the things I look for in successful people is like the people who operate like run a division at AESG. I don't want them there 100 hours a week. That tells me they're not good at their job. They are so good at their job, they make it look easy. They go home on time generally, Everyone works a bit hard sometimes on deadline, but they tend to go home on time. They have a life. It's not just like engineering 1,000% all day, every day. Do you know what I mean? And that is one of the other takeaways. An accomplished person like Nick is accomplished everywhere. Right?
Right. Yeah. That's very true.
Yeah, and people lose sight of that. Because, you think, oh, I'm going to dedicate myself, I'm going to become a master of this. And then before you know it, like your wife's leaving, the kids are going, who are you? It's like.
Yeah. Well, now that you say that, he made a statement, one source of truth.
Yeah.
But that has more applications than just the drawings. That's everything in life.
Well, this is a concept from the UK following the Grenfell fire. So, when they couldn't put someone in prison for that, they lost their goddamn minds to the government. And so they created this thing called the golden thread. So fire life safety engineers, and this will come to everybody in the end, right? All your decisions are now documented with a name. So the next Grenfell, someone will be responsible, right?
Yeah.
So they call that the golden thread or the single source of truth, right?
Right.
And the digital tools that we were talking about, Revit specifically, lend itself to that, because when there's one model everyone's working on, it becomes the data cloud dump for the job, right? There isn't, oh, well, my drawing says this and your drawing says that. That goes away, right?
Right.
There's, here we are. Who was last in that? Oh, Fred, you did that. What the fuck, Fred? Right? This is where people don't understand what's coming with all these digital tools. Extreme accountability is coming.
Yeah.
The ability to fluff it and was that your drawing? Was that Rev 5 or 10? That's all going away. And this transparency of who did what and transparency of performance is really going to change things. Yeah. It's just coming slowly. It's not coming right? But Nick's clients, that he tends to work at the top end of the market where people are okay with this and they have people on staff who can handle it. But that will diffuse down the same way CAD diffused down to everybody.
Man,
right?
I got a feel for Nick and people in Nick's position and your experience as well with the technology, because I got out of school the year that Autodesk launched the DOS version of AutoCAD.
Oh, how painful was that?
So our drafting and design class was all done by hand because we didn't have computer tools at the time.
Yeah.
And I followed that. And then when Autodesk went from DOS to Windows, it was a disaster. And I remember getting so angry because we couldn't get support. We were a small-time operation, taking the box that the software came in, putting it on the loading dock and turfing it into the parking lot. I was so mad. But they had at that time AutoCAD Lite, which was stable.
Yeah, I remember.
It was stable. Yeah. And so towards the end of my career, like I ran Excel and I ran AutoCAD Lite and I ran Visio.
Yeah, I still love Visio as well, because that used to handle CAD drawings, right?
Yeah. That was as sophisticated as I ever got. And I remember like the frustration I had trying to get the Windows version of AutoCAD. And then I think it was AutoCAD 11 to 12 or 12 to 13. It was somewhere in that time frame. And I just shut our operation down, and and so over the time, when you think about software glitches and the shit that software that delays, the parasitic losses, like having to pay people to redo stuff because something got screwed up, a file got corrupted, or somebody forgot to save the data, or like. And when I'm listening to Nic and other people we've had online, like my brain just spins. Like how
this is how I know I'm at the end of my career. I look at what Nic does, and I can open a Revit model just about and interrogate it. I cannot do a goddamn thing in that thing. I am just so not skilled enough to handle that. Right?
Yeah.
My time has passed. Nic is in his prime. I'm not. I'm like.
Unlike anybody. And he was saying that, kids coming out today are born, like they come out of the womb with the Revit capabilities.
So he's a generation better than me. And he's saying there's a generation better than him coming in behind, right?
Yeah.
So that makes you and me 2 generations out.
That's right. Yeah. Yeah, no, I'm with you. I'm glad I'm out of the game. And, but I'm also love being in the stands, watching these firms operate, because man, they're in a different world than I am. And that's why I asked the question about the parasitic loss, like the learning curve, and who pays for that.
Yeah, we do. Unfortunately, we speak about this a lot in AESG. Like, just a lot when we have to renew them licenses every year. You look at that number on a spreadsheet. Holy crap, that's a big number, right?
Well, yeah, and I don't know, man. It seems like these companies that are producing these software, for the fees that they're charging and how much learning that goes on, and then the feedback that they get, because they're improving the tool based on the failures that they're finding in the field.
Yeah,
I could be thinking there's going to be a return
department as well.
Yeah,
right?
There's got to be a return on that. Like I don't know. I've been talking to the people at Autodesk saying, well, we want shares.
Well, Autodesk is basically a monopoly that gets a free ride because no one understands construction and design. But they are a monopoly, and they abuse their power hard. I remember trying to negotiate the fees down on the catalogs. They laughed at me.
Yeah, right.
Not that
Mr. Muggleton.
This conversation is over. It's
pass you back to reception. Nice talking to you.
So that is one of the barriers to this filtering down to like vendors and contractors, is the fees. Because if you're a contractor and all you want to do is read some drawings and do a takeoff, you don't want the full Revit fee, right?
Yeah. So, it would be great if we could get Andrew Marsh on, who was a guy that started out as SQU1, and then he started Ecotech, which AutoCAD bought.
Right.
But you can go online, and anybody that's listening to the program right now, if you go to and just search for Andrew Marsh apps, and he's got these little modules, like a sun lighting shading module.
Yeah, so all the built-in stuff, right? You can add in, yeah.
And he's just like create these little Lego blocks of tools, apps. And I always thought that was brilliant. You didn't have to buy the whole smorgasbord and try and figure out what's on the menu. You just say, well, I'm going to go for a hamburger.
You're building your own Swiss Army knife at that point, right?
Yeah, absolutely.
Yeah.
And
listen, we better wrap up here, because the trouble talking to someone like Nic is it's really our wheelhouse, right? You can
totally. Yeah, totally.
Anyway, mate, that was a great interview. I'm looking forward to putting that one out. I'll see you on the next one.
All right, sir. Take care.
Take care. Bye.
Bye.
You've been listening to the Edifice Complex podcast with Adam Muggleton and Robert Bean. To access show notes for this episode, visit edificecomplexpodcast.com. If you have enjoyed this podcast, please leave us a review on iTunes. See you next time.